Hello, this is Dean Banerjee, and this is the Clock Architect Clock Designer tool. Let's suppose we've already gone through the tool, we found a list of solutions, and now we want to focus on simulating a particular solution and trying to optimize this. So let's suppose we are to choose this solution or whatever the solution we want, but we simply choose the one we want from the list and we say Open Design. By doing this, this opens up our simulation tool, which gives us much more flexibility and details upon that specific solution. So when we look at that, we see current consumption, bill of material cost, and footprint. We can go on each of these little pie charts and we can see how much of each part is consuming as footprint and BOM and current consumption. So we see the dominant parts here, which is dominating those things. We see the parts up here, this 3806, 913, and the 1102 here. For the 3806, we see it have outputs and loop filter. Among the outputs, we see clock out 1 and clock out 2. We see the difference is actually here is actually due to the different noise floor of the different output formats. So if we go to clock out, we can choose an output offset here. We can look at the integration limits. We can define what that's measured from. RMS jitter is traditionally what's used for clocks, but there's actually other metrics that are based on the area in the curve, so we can choose those or display what these interpretations of the area are under the curve. So we have all these areas hit there. If we go over to the curve here on the right, we can rescale it with the Y min and Y max. We can follow any of the curves and see specifically where it is. If one of the curves is in our way and we don't want to look at it, we can simply click it off like so by just clicking on the legend like that. So that's mainly the phase noise profile that we can see. We can also see like the 1102 is a buffer, the output formats is just flat noise. Now if we go back here to the 3806, we also notice there's a loop filter tab. So the loop filter tab has a basic and advanced mode. In the basic mode, we see this automatically picked everything from the parameters and it's come up with these components. And here is on the right here is a Bodhi plot. It's showing you the VCO gain, the closed loop gain, and various other parameters associated with this design. If you want to design your own loop filter, you can unclick auto and specifically give it a value. So for instance, if I give it 100 there and I say redesign, it's going to come back. Now these other three were auto. We see I said 100, it came back with 116. The reason why it's not closer than that is because this particular part has a partially integrated loop filter, which actually puts more constraints on what kind of loop bandwidths you can get. But anyway, we do have the components there. If you want to have more power and control in the loop filter tool, you can go here. It opens up many other options here. It opens up the gamma and other parameters here. As well, you can come here, you can specify the capacitor step. So by step, for instance, the capacitor might be 5%, but it's stocked in every other value, so they're 10% apart, or whatever the spacing is between the available values. Here, for every value, you could say, I want to calculate, or you can actually force a value there and say, I want to design around that. Here we have an integrated and calculate, so that means that the part actually has a list of integrated components there. There's multiple values it can pick from the integrated one, so when you say integrate and calculate, it's going to go and try to find the value that it thinks is best for that. The same for these other components. The other thing you could do, for instance, is you could unclick all the calculate. Suppose you have a loop filter and you just want to know what this thing says the performance is. You can do that too. You can go here and you can go to the top here. You can specify your charge pump gain, VCO gain, and everything there. You can go in the bottom here and you can say there. Now we already know the parameters of this, but let's just suppose I change this resistance from 220 ohms to 100 ohms. Now that's probably not going to be optimum, and it's not going to make the loop filter look very great, but just to show you that it can be done, you can go here and we should see the loop parameters change, and we see them actually change quite dramatically. This concludes this presentation.